Alright student, today we will start with the topic differentiation, and it is also one of those topics which is not asked at a very high difficulty level at any entrance examination. In fact, this is much more important in terms of your board examinations. So today in this particular topic we will be just covering the various types which are there in this particular topic, and we'll just wind up this topic very quickly so that we can move to the other topic, that is the AOD, in tomorrow's class, and we'll give attention to that also. Okay, just revise the concept that I'm going to teach you in the video, and I think this should be more than sufficient for your entrance examinations. Let's start the topic. Okay, so first of all we'll not be focusing our energy on the basics of the differentiation, that is how a product rule or a chain rule actually, or a quotient rule works. I hope that you people know all these concepts. That is the reason I'm taking it forward, and I'll be applying those concepts in the questions or the lectures that I'm going to take today. Alright, so the first question, without giving any thought, let's start with it. It says fx is equal to, right, so fx is equal to log with base x with input is also log x, right? This is the question, and you need to find f dash x at x when x is equal to e. This is the target. This is what you people want to find. Okay, so now understand this. The question that I have taken over here is just to explain you how the log machine works. All right, this is something very important here. So there is a formula where we can use the concept of log, which says log a by with base b. If you want the base to be, let's say, 10, then you can do it in this fashion. This is the formula that you people should actually know all about. Okay, so if you try and use this formula, why I'm using this? Because when you say, everybody knows that the derivative of log x is nothing but 1 by x. Everybody knows this, right? But you have to keep in mind that this is only possible when the base is e. So for example, if it is given that differentiate log x to the base 10, and if you answer this, the derivative of this to be 1 by x, then obviously you will fetch no marks. This is completely wrong. So for this, if you want to do this, what you will have to do is you will have to change the base. So what you will do, something like this. You will write first of all log x with base 10 as log x to the base e, and log 10 with base e. Now this is a particular constant. It can be taken outside the derivative. It has no role to play inside the derivative. So what you people will write is something like this now. Okay, and then you can say that derivative of log x to the base e is now 1. So the answer is 1 by x upon 1 by log 10 to the base e. So this is the answer to this particular problem, right? So this is not equal to 1 by x. Again, a very basic stuff, and it is being regularly asked at the CBSE or the board levels. Okay, now coming back to our question here, it says that you were to find the derivative of this. So again, the problem remains the same. In fact, in the base, now the base here is x, right? And we want our base to be equal to e. So that means we'll have to change the base, right? So we will swap the base, and we can write something like log e of log x divided by log x with base e. We can write like this. Okay, so the same function can be written like this. Now you want to differentiate this function, right? Now you can differentiate, and for differentiation, obviously now we'll be requiring, yes, we will be using quotient rule. So just quickly apply this. So what is the derivative of log x? So this is actually the chain rule here. So if I take a gx function as log of log x, right? Now I can say this is nothing but log of log x, right? So what will be the derivative of this? Yes, it will be 1 by log x, right? That is the derivative of this. Then again, what you will say, you will go inside the function. So those people who are not comfortable with the chain rule, let me just explain very quickly. It is, so there are composite machines, right? Log ke andar log okay, so I see something of this sort, that log fx. So initially, which machine is working? The first machine that is working is the log machine. So what is the derivative of log? It will say 1 by fx. But since the second machine was not x, it was f, I will again go and differentiate f, and I'll keep on doing this process unless and until I get to x. This is how chain rule works. Okay, so what you will do here is 1 by log x because of this particular log, and then you will differentiate the inner function, that is log x. So the derivative of log x is nothing but 1 by x into, yes, into the denominator function, that is log x, minus what you will say now, the derivative of the denominator, whereas this will keep as it is. We'll keep this value as it is, and now derivative of denominator will be nothing but 1 by x, right? And you will divide this whole function now by the square of this denominator. So this is the particular value that we were looking for. Now this is the value of f dash x. You were asked to find f dash x at x equal to e. So you just want to put x equal to in e in this particular expression. So if we talk about x equal to e, then log of e with base e obviously will be 1. So just see what we will get. So everywhere wherever you will find log, this will become 1, because log e with base e will be 1. So this becomes 1 by e. This will become 1, 1. This will also become 1 minus this is log. Yes, this will be what? This particular stuff. So this will become log of 1. Log 1 is nothing but 0. So this entire stuff becomes 0 and this is your answer. So 1 by e is the answer which is given in the D option. This is how you solve this. So this is the question that I have taken this one is basically for your basic part, that how you apply the quotient rule, how you solve the log x part. Keep in mind that you always have to take base e. That is why we say derivative of ln x, not a derivative of log x. So derivative of ln x is nothing but 1 by x. Keep this in mind, not of log x with base 10. Okay, let's move forward. Okay, now let us take another basic question before we proceed to the concept part. It says, it's a very lengthy at the first go, right? If you see, it looks like very intimidating, that it's a tough problem. You will say that it is a tough problem. Let me just show you that it is in fact very easy to solve. So okay, so this is the first tan inverse, and the other tan inverse is this particular function. Okay, now think of it how you are going to solve this. You want to find the derivative of this, and mind it, derivatives have not you should not apply derivatives blindfolded. What do I mean by blindfolded? It should not be that you start differentiating these values. Differentiation is at your level is not meant to solve very huge functions. So whenever you see a very huge function, something like this, your target should be to simplify first of all. So the question is not asking you to differentiate. Actually, the question is asking you to simplify these terms first of all. Then if I give you this hint, then you will immediately think, sir, this is something of the sort tan inverse A plus tan inverse B, right? And everybody knows the formula for tan inverse A plus tan inverse B. So they immediately start applying this. But again, if you notice, this is very cumbersome, right? The A is a huge number, B is also a very huge number. So again, if you start simplifying by this formula, this is not the way it should be. So let me take the first function, which is here tan inverse log e by x square, right, divided by log ex square, right? In this particular chapter, wherever log is given, we will take log with base e, all right, from now onwards. So can we simplify the inner part of this first of all? Just think of this. So if we start doing this particular, so what we will get? So I can say log a by b is nothing but log e minus log x square, right? So this is actually using nothing but concepts of log, and this can be written as log e plus log x square. Any problems? And what we can say about log e? Log e is 1. This 2 will come outside. I can say 1 minus 2 log x, and the denominator will become 1 plus 2 log x, right? Now if you can see what formula it would be. If I say this is the formula here, can I say that tan inverse of a minus b? Yes, now you are getting what I am trying to make out. So this can be written as tan inverse a minus tan inverse b, right? Isn't the same thing happening here? See, this is the value of a is 1, here the value of b is 2 log x, right? This is the same. So can I say this is nothing but tan inverse 1 minus tan inverse 2 log x? Very simply, right? And now simplify the next bracket also. Now the next part is actually solvable. If you see that we wanted to solve tan inverse 3 plus 2 log x upon 1 minus 6 log x. It's already there. Here if you see, the value of a is 3 and here value of b is 2 log x. Can you see that the direct formula is there? If you just check this formula, this is already applicable here, right? Clear? So what we can say about this particular quantity is that this will become tan inverse. Tell me. So it will be nothing but tan inverse 3 plus tan inverse, yes, 2 log x, right? So you want these two quantities to be added. As simple as that. What is the quantity that you will get? These two will get cancelled out. So what is actually the function? Now you can see how simple the question was. So y is nothing but tan inverse 1 plus tan inverse 3, and we need to find the derivative of this function. We wanted dy by dx for this. So dy by dx, what will be the value of dy by dx? It is 0. That's it. Why? Because these are both constants. So derivative of constant is nothing but 0. So you can see that this problem looks like to be a very intimidating problem, very big problem at the first go, but it's actually very simple. The answer is in fact 0. Let us start the very specific category of differentiation, that is logarithmic differentiation. And as the name suggests, you will be taking logarithm before differentiation. So for example, you want to find the differential coefficient. So what do you mean by differential coefficient over here? So differential coefficient is nothing but you are asked to find dy by dx of x raised to power x plus log sin x. So when you will use logarithmic differentiation, just try and understand first of all. So whenever you find something of the sort variable raised to power variable, right? So this is a big hint that you will have to use logarithmic differentiation. Very big hint. This is a big hint, right? That though there are other methods also by which you can solve, but this is a big hint for logarithmic differentiation. And since we know that dy by dx can be split up and it could be distributive in nature, so you can differentiate this first, you can differentiate this separately and then add both of them. So for example, if I say dy by dx of x raised to power x, let's just solve this first, right? So what you people could have done, let's say a is equal to a function which is x raised to power x. So I can take log a is equal to x log x. Why I am doing this? Because it is again variable raised to power variable form. And now start differentiation. Now you can differentiate. So differentiation of log a would become 1 by a dA by dx, right? If you apply chain rule. And what will be the derivative of this particular function? You will apply product rule. So this will become log x, the derivative plus 1, right? And if you solve, you will get that dA by dx is nothing but a times log x plus 1, and again you replace the value of a, which is nothing but x raised to power x 1 plus log x. So derivative of this complete function, you wanted dA by dx, you have already got this. Similarly, you can take the other function is b, right? Log x raised to power sin x. This method you can easily apply in your board. That is the reason I am taking this in this particular lecture, right? So log b, this will become sin log of log x, right? Now again do the same step, that it will become 1 by b db by dx, and here you will again have to apply, yes, you will again have to apply here product rule. So cos of log x plus sin x by log x, and then chain rule also, because log of log x ka derivative would be 1 by log x into derivative of log x, that is 1 by x, right? And then you will have to again multiply dv by dx, will go, that b will go here. So the answer to this particular will be log sin x raised to power sin x, and this complete multiplication over here, right? This is cos x into log of log x plus sin x by x log x, right? And you want these two quantities to be added. This is the particular answer. Okay, so this is how you have to solve, especially in your boards, right? In your boards level, you will have to solve something like this. Though there is a shortcut for solving variable raised to power variable form, let's see how it is. So for example, it is given to be x raised to power x. What I can use the formula of exponentials, that I can say this is nothing but equal to this. So those people who do not know this formula, the formula is a raised to power b is nothing but e times b ln a. Or even if you want to check this out, this could be written as c b times ln a, not ln, in fact you should write log with base c. So this base and this base of log should be same for the formula to be there, but we generally use this particular formula So I am removing the, or you can say just remember this particular case, right? Let me not remove it, but yes, this is the formula. So if you know this, then this problem really becomes very easy. Now you want to differentiate this, so you will differentiate it something like that. I can see e raised to power fx, so derivative of e raised to power fx would be then dy by dx of this particular function would be e raised to power fx into f dash x, right? And simply now you can solve this. E raised to power fx will again become x raised to power x, because this is nothing but x raised to power x, and then f dash x will be the derivative of x ln x. And if you see and compare, we are already at this particular stage. You will get this answer only. So this is the shortcut method of doing variable raised to power variable form, that you express this into e variable 2 ln variable 1. If this is variable 1 and this is your variable 2, okay? The other category of questions where you apply logarithmic differentiation is something where under roots and multiplication is got. This is the standard problem where you apply logarithmic differentiation. So here it is given that y is a very complicated function of under root and product, and which is divided by a fraction also. So this is a standard problem. I hope everybody is clear with this. You will now know that you will have to take, yes, you will have to take log on both sides. So if I take log on both sides, this will become 1 by 2 log of this whole particular stuff. And yes, you are right, you must be thinking that this is a very simple problem that I have taken. I just taken this to highlight how you should apply and when you should think of logarithmic differentiation. And this is much more easy if you apply the property of log now. So this becomes, actually this will split into 4 logs. So log a x minus a plus log x minus b, this is for the numerators. Denominators go in the minus sign, log x minus p minus log x minus q. Very simply done. Now just quickly differentiate this, right? So this will be 1 by y dy by dx is equal to 1 by 2, and this will be nothing but this will reduce to x minus a plus x minus b minus x minus p and minus x minus q, right? And then quickly send y across over here. This is how you solve this particular problem. I hope this is clear. Nothing more is left in this. Let's take another different problem of logarithmic differentiation. Now here you can see it's a 3-tier problem. Variable raised to power variable raised to power variable. Right? Now here the formula for E seems to be a bit complicated. First of all, it is something like it's a tree system where it is 3-tier system. If you just take log, don't worry about what you are getting. So if you just take log, so what you will get, yes, you will get 10x raised to power 10x. This is the, this is the, for this whole stuff is the power, and this will come out very easily, very easy stuff. So this becomes log 10x, as simple as that. So again, if you start differentiating, it will be 1 by y dy by dx, and you will have to apply product rule over here as well. So this is the derivative of this particular component. We'll keep this as it is for this, right? And how you will differentiate this now for the product rule, the second component, right? Now you want to differentiate d by dx of 10 raised to power 10x. Now we can do this, right? We can easily do this. We just did this earlier, right? So you can assume, if you want, that this is your a, which is 10x. You can, in fact, you can write like this in your board examinations, no problem at all. So you can write this as e raised to power 10x ln 10x, right? And now you differentiate it. So if you differentiate, the first step is always that if you differentiate e raised to power, so this is a hint. So if you differentiate e raised to power x, you get e raised to power x only, right? So whatever it is, so the first step would be e raised to power this only. You will immediately get this again. Repeat this if you are not clear, right? So why I am doing this? Because I know that e raised to power fx, derivative of e raised to power fx is nothing but e raised to power fx you will get again into differentiation of the power. So that means if you differentiate this, you will get this entire value into derivative of the power, that is 10x into ln x or ln 10x. Now where you will apply product rule, right? See, so I will leave this part for you people to solve, because this is nothing left in which I have to explain. Okay. Okay, now let us take derivative of implicit function. So let us first of all study that what do you mean by an implicit function, right? What is the definition of an implicit function? So implicit function, what we people have actually studied is that we generally do y is equal to fx. So here we can represent y and x separately. That means LHS is all y and RH is all x. That means you are able to separate them, right? They can be written separately. For implicit function, you will not be able to write them separately, right? So you cannot separate x and y, then we will call this as implicit function. Okay, so for example, if I am taking this sine of x plus y is equal to xy, so whatever you do, you will not be able to write y is equal to fx sort of thing for this particular function. So this is the category of implicit functions. So here the question that is given to you is 1 plus y times 1 plus root x equal to 0, and you are asked to find the value of dy by dx. Okay, so always whenever we see square roots, what do you people think first of all? So yes, the first target of the square root should be to do square very simply. So but we will not do the square like this. What we will do, rather we will take it here and now we will do this step, right? Very obviously. So if you square, what you will get, 1 plus y is equal to y square and 1 plus x, right? Okay, so yeah, okay, then let's just correct it because this was x also here, so this will be x square. Now yeah, now this is fine. So now if we start forming the equation, first of all this will be x square plus x square y is equal to y square minus y square plus y square x, and if we take all the terms on the same side, so this becomes x square minus y square plus x square y minus y square x, right? And very easily we can see that we are getting common over here, that is x minus y into x plus y over here, and if you take the xy part over common here, you will get what, x minus y here, and easily this could be written as x minus y into x plus y plus xy. Okay, so these are the two components that we will get. So either x could be equal to y, or you will say that x plus y plus xy is equal to 0. So if you simply differentiate here, you will get that dy by dx is equal to 1, right, which does not matches with your any further answer. Though I can explain you with other concept that this is wrong, but for the timing just stick to this, that this does not matches with any of your answers. Let's try with the other component that we have obtained. So this is the other equation that you have obtained. So now you have x plus y plus xy equal to 0. Okay, so if I collate the terms of y, what you will get, that 1 plus x times y is equal to minus x, or I can say y is equal to minus x upon 1 plus x. Just do the differentiation again. So dy by dx for this particular component would be what? So this will be minus, let's say minus we'll take outside, so 1 plus x, the derivative, because derivative of x is 1, and this will be minus x divided by 1 plus x whole square, right? And if you cancel these terms, obviously you will get 1 upon. Now if you try and match, yes, you have a answer which is there, okay, which is the b part. So b part is the answer we are looking for. People who are thinking that why we are getting two particular answers here, that dy by dx equal to 1 and dy by dx equal to minus this, simply because here what we have done, square. So squaring will always give you two answers. Mind it, if I have been taking the advanced class, I would have taught you why we are getting two answers. So for always, if you do square, beware that one redundant answer will always be there. There will be one redundant answer every time, right? But this is out of the scope. Don't worry too much about this. We are not going to cover this here. I hope the question is clear. Then let's take another problem on implicit function. So it is saying that x raised to power y plus y raised to power x is equal to a raised to power b. Now you want to find the value of dy by dx. So in fact, if you see, it is again variable raised to power variable form. So if I take capital A to be x raised to power y, your target is to find dA by dx over here, and you can easily see now that I can write this as y ln x, and then again start the process as we did in the earlier part of this video. So it will nothing be x raised to power y into derivative of y ln x, which we can say is dy by dx ln x plus y by x, right? This will be the answer for this. And if I take b to be the other part, that is y raised to power x, similarly I can write this as e raised to power x ln y, right? And again our target is to find db by dx, so this will become what? Y raised to power x into, that is derivative of this particular quantity, which is ln y plus x by y dy by dx. Okay, so this is what is the answer, and because the right hand side is obviously 0, so don't worry about it. So what you will do, you will add these two values up and equate them to be equal to 0, and then try and find dy by dx. This is the standard approach that you people know, and people can apply also. I am going to teach you some new approach. So let's say the trick method. Okay, so trick method, and please don't apply this trick method in your board level, right? This is specifically for your entrance examinations. So what is the trick method? So it says that write the function that is given to you in terms of x and y as a expression. So the expression would be function of this entire thing would become something like this, right? You need to find dy by dx, right? What we can solve is, you can say dy by dx would be nothing but, now I'll tell you, I'm going to tell you a formula over here. This will be minus times delta f by delta x divided by delta f by delta y. So what do you mean by delta here? Delta is the significance of partial differentiation. I am just going to teach you what do you mean by partial differentiation over here. Okay, so this is partial differentiation. Now let me show you how it is being applied over here. So first of all, the target is delta f by delta x, right? So delta f, so in terms of, let's say, partial, right? Partial differentiation. You are differentiating with respect to partial differentiation with respect to x. So this means here y will be a constant. Y is not a variable in this now. Y is only a constant. So if you want to differentiate this with respect to x and in terms of partial differentiation, so here now no longer it is a variable. So you will say that this is equal to x raised to power y. So it is something like saying x cube or x raised to power n. So what is the derivative then? Y x raised to power y minus 1, right? Y raised to power x. So y raised to power x, this particular step for me is nothing but a raised to power x, because y is a constant, remember. So a raised to power x, what is the derivative of a raised to power x? Yes, y raised to power x ln y, right? That is derivative of a raised to power x is a raised to power x ln a, and this is constant. So this is delta f by delta x. Got it? This is the first expression. Now you need to find delta f by delta y also. Now in this particular case, what you will do, you will take, for this you will take x constant, right? We will be taking x as constant. So now let's start differentiating. So x raised to power y, so this seems to me a raised to power y, right? So what will be the derivative? X raised to power y ln x plus y raised to power x is something y raised to power n, so this will become x y raised to power x minus 1, right? And again it will be 0. Now your target was to find dy by dx. We have already written that it will be minus times delta f by delta x, right? So this will be y x y minus 1 plus y raised to power x ln y whole divided by x raised to power y ln x plus x y x minus 1. Now if you see, your answers are also arranged in some similar pattern. Can you tell me what is the answer now? Very simple, right? It's here. It's simply written over here. So C is the answer. So you are actually saved a lot of time by doing this particular trick method, because you would have to solve and rearrange. So if you see, there are 3 steps involved in the basic problem. First step, second step, and the third step is you will solve the equation, arrange dy by dx on one side and do this. Now I'm not saying that this is tough. This is a very easy method, but it's a bit lengthy method, right? And this trick method will obviously cut down your time. I hope this is clear. Okay, now let us understand the derivatives of composite functions. So we know that composite functions are something like f of g of x, right? fog function, we have studied Goff function, and these kind of functions are known as composite functions, where they are a two-tier machine, right? We just did this step, these things in the functions, right? This is something how it is working. Machine 1 here, machine 2 here, and then you will get something of this sort, machine 2, where input is machine 1, right? So how do we differentiate this particular step? So if I have to say, just teach you that what is the derivative of f of g of x. If you want to differentiate this, so the derivative would be nothing but f dash gx. This is simply chain rule, right? Don't you worry about it. This is the very basic stuff that we are doing, into g dash x. So this is now, let's apply this into the question. It is said y is equal to f of, so it's not fx, y is not equal to fx, it is y is equal to f of this. So this is the input right now of this particular function, and you are given that f dash x is equal to sine square x. This is given to you. Now your target is to find dy by dx of this particular question, where y is given into this particular term. So if I start differentiating this, what value you expect to get? So if I say dy by dx, so what you will get? F dash of 2x minus 1 by x square plus 1 into, yes, derivative of 2x minus 1 by x square plus 1. This is how you should think, like when you are seeing a composite function. So this part is pretty easy, I guess, right? You people can solve this part. Okay, now the target is to solve this particular component over here, because we do not know the function x. How we are going to solve this particular step over here? Okay, so let's see. This is simply very easy. You just have to correlate these two. So you know f dash x is nothing. So if I say that this is y, right? So you are targeting to find value f dash y. F dash y is nothing but sine square y. Now you are getting what I'm trying to tell you. So yes, you just simply replace this entire value that is there over here. So simply the answer to this particular problem would be sine square 2x minus 1 divided by x square plus 1 into the derivative of this particular function. Okay, so I'm leaving that particular component of derivative here for you people to solve, because that I believe is very easy to solve now. Okay, let's take this forward and apply this concept in a difficult problem. Okay, so this is the next problem that we people are going to solve for the composite function. Again, if you see that y is equal to sine m into sine inverse x. So this is a composite function where this is the first function and this is the second function f2, and this could be said as f1, right? So now you are asked to find this particular system. So it now also obtains the second derivative, right? This is actually second derivative, which we are going to study as we are progressing, right? So it says dy by dx is equal to, what we can say now? What is the so derivative will be cos of m sine inverse x, right? And then what will be the derivative of this m into sine inverse? What is the derivative of sine inverse? Which is 1 minus x square. Okay, so this is how it will be treated. Okay, and if I do a cross multiplication, what I can say that 1 minus x square dy by dx is on one side, and this becomes m into cos of m sine inverse x, right? But this is still dy by dx. You need the second derivative also. So what we will do, we'll differentiate it once again. So if we differentiate this once again, let's see what we will get. So this will be 1, and this, yes, the derivative of dy by dx is known as d2y by dx square. Okay, plus what you will get, what you should get over here is 1 by 2 under root 1 minus x square minus 2x. So believe me that many of you will miss out on this. I don't know why you people miss out, but yes, this is a common error that you people do. Please be aware of it, that if you have to do this, you have to complete the chain rule. So 1 upon 2 under root 1 minus x square, and then you will differentiate 1 minus x square also, which is minus 2 over here. Now if you start differentiating this will be m minus sine m sine inverse x, and then you will again differentiate m sine inverse x. So this will be m upon again under root 1 minus x square, right? This is what you people will be expecting. Now the question is over. You just have to arrange the components which are there. Let's see how we can do this. So it will be, if you cross multiply this under root 1 plus m square, right? This particular component, you cross multiply, what you will get? This will become 1 minus x square into d2y by dx square. Under root here will get cancelled out. 2 is also getting cancelled out. You will get minus x dy by dx. What this will become minus, if you see, this again is nothing but y. So these kind of questions are very common, where y will again reappear in the question or the answer. So this is nothing but y component. Got it? So this complete thing can be written as m square y, and if you compare, you have actually got your answer. Now if I, yes, clear, if I just put them on one side, this is what is actually required in this particular answer. Though composite function is a very easy topic to solve, it does not require very hi-fi concepts, very simple stuff, right? This is your answer which was required. I hope this is clear. Okay, now let us understand the concept of parametric function, or maybe the differentiation of parametric function. So what is a parametric function first of all? So parametric function is, now we generally do y is equal to fx, right? So now this is not the case. Here y is, let's say, a function of theta, g theta, and x is also a function of theta. So here parameter is theta here. Okay, so parameter is nothing but theta. So both the functions x and y are in terms of theta, but you are still being asked dy by dx. Whereas if you see, y does not have any component of x, so it should be that you cannot solve this, but this is not the case. You can solve this by doing, yes, you are right, that dy by d theta, that is differentiate this quantity with respect to theta, divided by dx by d theta, that is differentiate this particular quantity with respect to theta, and solve this. This will give you eventually dy by dx. This is how you solve these questions. So let us apply this particular concept that we have just studied in this particular concept, or sorry, question. It says x is equal to secant theta minus cos theta, right? So if you can see that x is a function of theta, and similarly if I write y, I can easily see that y is also a function of theta, and by just reading this I can say that this is a equation on parametric form, because you are asked being dy by dx square. So let's start with dx by d theta. So what you will get as dx by d theta, what is the derivative of secant theta? Secant theta into tan theta, and this will be plus sin theta. Got it? What can I say about this now? Okay, so this does not seem that any further step could be done. Now again go back to the question. Let's see the option C of 3 options that are given to you. They are all in terms of x and y, right? They are not in terms of theta. So that means this particular question over here is also of the category eliminate theta, that you have to eliminate theta. It is very obvious that the derivatives that you will obtain will be in terms of theta, but the answer is not in terms of theta, so that means you have to eliminate theta somehow or the other. So if I go ahead and do a further step, let's see what I'm going to do. So tan theta, if I take common, what I will get over here? Secant theta minus cos theta, sorry, plus cos theta, because they are plus now. Just see to it. I have did that, I did divide and multiply by cos theta over here, so this becomes tan theta. So this is what I can say. Why I have done this? Can you tell me why I have done this? Yes, the reason is why, because I can write secant theta plus cos theta in terms of secant theta minus cos theta, right? Just understand, this is a concept of quadratic actually. So this could be written as secant theta minus cos theta square, right, plus 4. Just check now, I'm giving you time. So if you open this, this becomes secant square theta plus cos square theta plus 2, oh sorry, minus. So here you should have got actually, let me just highlight this for you. So you should have actually got secant square theta plus cos square theta, and this would have been minus 2 secant theta cos theta, right, plus 4. Check this, this is nothing but, yes, this is minus 2 only, because secant theta and cos theta will get cancelled out, and if you see plus 2, got it? So this actually becomes nothing but secant square theta plus cos square theta plus 2, which I have already written. And what is the benefit of doing this particular step? Yes, now you see that secant theta minus cos theta will get converted to easily x square. So I have actually written my dx. So if I go back and write dx by d theta can be written as tan theta into under root of x square minus 4. This is what I can write. So now I have introduced x again in dx by d theta. Now my target is to do something similar with y and write dy by d theta in terms of tan so that this gets cancelled out. Let's see if I can do this over here or not. So if I do dy by d theta over here, can you tell me what expression I will get? Let me just solve it here. So it will become n times secant n minus 1 theta into secant theta tan theta minus n times cos of n minus 1 theta, right, minus sin theta, and that means this will become plus. So again, if you see here, what can be taken common? Quickly tell me. Okay, so immediately everybody would say, sir, n could be taken common, and if I start and doing clubbing, so it will become secant n theta tan theta. This will be what? Cos n minus 1 sin theta. Okay, clear? So again think on the same terms as we did here. You want to make again y over here. So for y, what is the y? Yes, this is the value of y. You have sin n theta, but you also wanted cos n theta. What you are actually getting is, yes, so if I say that I multiply and divide this particular quantity by sin cos, I can do this step where this is multiplied by cos and this is divide. So what this particular term will come out to be? Can you tell me? Yes, now tan theta will come out, and this is much more beneficial because you wanted tan theta to come out, right? So this entire thing can now be written as what? This will be written as n tan theta into secant n theta plus cos n theta, right? But now the problem is that here in y we were having minus, here we are having plus, the same rule, right? So treat this as this is your complete a. So this is something a plus b. You were given that a minus b is equal to y. How do you calculate a plus b from this? We know that a plus b in terms of this will be nothing but under root y square. Similarly here, see to it here, what, plus or minus? Yes, it would be plus 4. Why plus 4? Because we know that 2ab term will again cancel out because both are reciprocals of each other, right? Write them on pen and paper and you will be able to solve what I'm telling you. Okay, and okay, yeah, so let me just do a rectification that what we should write over here. Can you tell me? Yes, so it should be a positive sign. Okay, just change this because here it is plus 4. So now your answer here reduces to n tan theta under root y square plus 4. So this is nothing but what you have got for dy by d theta. Your target was to find dy by d theta whole square. I hope now you have got what I am trying to do. So dy by dx is nothing but dy by d theta divided by dx by d theta, and if you see that tan and tan will get cancelled out, right? What you will get, n under root y square plus 4 divided by under root x square plus 4. Okay, so this should be the answer, and in fact we wanted the square of this, so this, just do the square and tell me the answer. So this C part is the option. Okay, so I hope this point is clear. I have taken a very difficult problem straight away for the parametric function because I believe this is very easy concept. Everybody must have done that them at their boards. I have taken a very specific problem which involves a lot of trigonometry, because this is how you actually revise trigonometry, and a specific problem of eliminating theta in this, and how do we solve these kind of questions. I hope this question is clear. Okay, now let's start with differentiation using substitution, where you have to use trigonometric substitution majorly over here, and you will actually have to remember the basic substitution rules. What I can help in this is I'll send you a sheet which actually covers the basic rules of substitution. In fact, this is given in every package. If you are going to an institute, you must be having that also. For those who are not going, I will send it across, don't worry about it. Okay, so this is what you people have to solve, tan inverse of this and this. This is a huge thing, right? And you want to do a derivative of this, that is, you want to find derivative of this particular function, right? Okay, so whenever you are given an inverse function, your target, so if I have to reiterate the target, so here you are given a function which is in terms of tan inverse, right? Your target should be to have something of tan theta inside so that you get answer theta. So this should be your target first of all. Okay, so here in this particular case, the entire this function, that is the interior function, should be reduced to something of tan fx. This is the target, so that if I write tan inverse of tan fx, the answer would be only fx. How we will do that? For this you have to remember the trigonometric formulas. How you can solve something by putting x, so that 1 plus x square is also reducible and 1 minus x square is also reducible. Tell me. Yes. So how we can solve is x square, let's x square be cos theta, or let's say for that matter cos 2 theta. Okay, so this is how you will actually help to remember all this. Those who are not able to get grasp of it, you will have to remember this, how we are doing the substitution. I'll send you the sheet across. So what is 1 plus x square? So 1 plus x square is nothing but 1 plus cos 2 theta. So what is 1 plus cos 2 theta? Yes, it is nothing but 2 cos square theta. And if I have to say 1 minus x square, so then it will be 1 minus cos 2 theta. This will be what? Yes, it will be 2 sine square theta. So now you understand why I have taken this particular kind of substitution. Okay, so we know this now. Let's start putting these values in the function now. Okay, let me just change the color of the pen. So it will be, yeah, tan inverse. So this will be 1 plus x square is, yes, 2. So it will become what? Root 2 cos theta. What will be the next bracket? Yes, it will be root 2 sine theta. Similarly, here in the denominator it will be root 2 cos theta, and this will be what? Minus root 2 sine theta, right? If you can see that all the roots will get cancelled out, what you will get? Y is equal to tan inverse cos theta plus sine theta divided by cos theta minus sine theta. And now how you solve this? Again, now remember this, something you have to remember some things to pick up your speed, right? So this is nothing but tan of pi by 4 plus theta, if I have to remind you. If people who are not able to recognize this, just divide this by cos theta, right? So this will be something of this sort. Now you can very well say that this is nothing but tan inverse of tan, yes, pi by 4 plus theta. Now you can say. So in fact I would now recommend that you should read this as a formula, right? Add this to your formula list. This should be a formula for you people, that this particular value is nothing but this particular quantity. Okay, so now just taking this step ahead, so now tan inverse of tan theta will get cancelled out. What you will get effectively is y is nothing but pi by 4 plus theta. Now you need the value of theta back in the question. That is the problem. So now you have taken, in the initial part, you have taken cos x square is equal to cos 2 theta. So what will be the value of theta here? Yes, you can take cos inverse x square is equal to 2 theta. Then I can say theta is nothing but 1 by 2 cos inverse x square. This is the value of theta. So just replace it over here. So sorry, now you can see that you have got this particular function explicitly in terms of x. You wanted dy by dx, so now you can differentiate. So dy by dx is nothing but this will be 0, this will be 1 by 2. What is the derivative of cos inverse? Cos inverse is minus 1 upon 1 minus x square, so this will be x raised to power 4, and then you will differentiate x square also, which will be 2x. Got it? So answer to this particular problem would then be minus x upon under root of 1 minus x raised to power 4. This is the answer, okay, which is here in the C option. Clear? So again, remember that what substitution has to be done, you have to remember this, then only your problem will become easy. Okay, now let's take another question based on the substitution. It says under root of 1 minus x square plus under root of 1 minus y square is equal to a times x minus y, right? And you need to find dy by dx. So at the first, it does not looks like a trigonometry problem. Generally, you get trigonometry problem, the hint of trigonometry problem when inverse is there. So whenever there is an inverse, let's say if I talk about the previous question, so remember this as a hint, or you can say this is a formula for you people, that whenever you are given a inverse, let's say tan inverse, secant inverse, or whatever, and inside them there is algebraic function, right? There is algebra. So this algebra has to be substituted in trigonometry term. This is a great hint, great hint. But if I see this particular question, this is completely algebraic. There is no inverse. So we do not immediately get a hint that this is a substitution problem. But whereas this is a substitution problem, let's see how. So if I say that, let me assume that this particular x square, right, over here is a cos a function, and y over here would be cos b type function. Okay, so now I'm trying to reduce my all question in terms of a and b, right? So let's see what actually the question now will become after doing this particular substitution. So this becomes 1 minus cos square theta sine square a. So this becomes sine a, plus this will become sine b. This will be what? A times cos a minus cos b. Any confusion till date? Okay, so what is sine a plus sine b? Yes, we know this formula, that this becomes 2 sine of a plus b by 2 into cos a minus b by 2. And what is the formula for cos a minus cos b? Yes, it is cos sum by 2, then cos difference by 2, right? Okay, and if you see that we can immediately cancel the term cos of a minus b by 2 from here, right, on both sides. So what you people are going to get, or and also you will get a 2, we can get 2 cancel also here. So what eventually we are going to get in this particular question would be sine of a plus b by 2 is equal to a times cos of a plus b by 2. And if I move this cos over here, this will become tan of a plus b by 2, right, is equal to a. Okay, and now I can write this particular quantity as a plus b by 2 is equal to tan inverse a. Now the question, coming back to the original question. So the original question was in terms of x and y, or you can say this a plus b reduces to, yes, 2 tan inverse a. Okay, so what was the value of a? Can you tell me? From here the value of a becomes cos inverse x, and the value of b can be written as cos inverse y. Now substitute these values back again here. So if you see, either you say that this was your original question, or the question that has been now rewritten is this. So these two things are actually the same. So it is much more easy to differentiate this particular quantity as compared to this particular quantity. Now you just differentiate. So if I differentiate, this becomes 1 upon under root 1 minus x square minus y by under root 1 minus y square dy by dx, and this is completely a constant, right? So the derivative of this will be nothing but 0. And if you now see and check the answer, we already have the answer now with us. So it is nothing but that dy by dx will be equal to what? Just put it to that particular side. So what you people will get, sorry, this y will not come here. Okay, so that's not a problem. So what you people will get as the answer is, yes, under root 1 minus y square upon under root 1 minus x square. So this is the answer we were looking for. That is the B part. Okay, so this is how we are going to solve these kind of problems whenever they come. Okay, now let's take another problem on differentiation using substitution. So it says tan inverse something. So again, if you see, it is tan inverse something of algebra here. So whenever you are getting this, so that means this algebra by using substitution, right? Substitution has to be reduced to a trigonometric identity, trigo, which will be something of tan theta. Then only I can use tan inverse tan theta to reduce this particular problem to theta. This is the workflow of these kind of questions. Okay. But this question is asking a very specific formula that we will be using, which is this particular formula that I have mentioned over here. That is the formula of 3 tan inverse x, which is 3x minus x cube upon 1 minus 3x square. So now if you compare, this is somewhere similar to this, but not exactly similar to what we are trying to obtain. So let's see how I am going to change this entire thing. So let's say if I call the interior of, I see this as tan inverse fx, right? So this fx function I can write as 3 a square x minus x cube divided by a into a square minus 3x square, right? So what is fx in terms, I need to write fx as 3x minus x cube upon 1 minus 3x square. This is how I have to write fx. Okay, so can you think of how you are going to write this particular stuff? Here you require x, here it is a square. Okay, and if you even divide by x a square, then this will become, let's say if I do this for you. Okay, so this is x minus x cube by a square, and I'm dividing this stuff by a square only, right? So this is what you will actually obtain, which is something very weird. You do not get anything productive out of this. What if I do something where I divide this by x a cube? So if I divide this by a cube, something of this sort will be reduced to, let's say, this type, and the denominator would be a will get cancelled out, and just I'm doing the straight away step. You people just see to it whether you are able to understand it or not. This is what you will get. Just see to it. I have divided this particular step, divide by a cube, rather than being a square, I divide this by a cube. So this is what you will get. And if you now see that if I place x by a to be t, right? So this is nothing but 3t minus t cube upon 1 minus 3t square, which is exactly similar to what I require. So this actually becomes what? If I put this now into y is equal to tan inverse, let's say I write this like as 3t minus t cube upon 1 minus 3t square. Okay, so this would be what? 3 tan inverse t. That is the formula. And now you can substitute the value of t. The t is nothing but, yes, t is 3 tan inverse x by a. Okay, so this is y is equal to 3 tan inverse x by a. Now you can easily differentiate it. Now I guess nothing is left for me to solve. So this is dy by dx is equal to 3 derivative of tan inverse x is, yes, 1 plus x square by a square, and then you will differentiate x by a, which will give you a also. So the answer to this particular problem, if we talk about, is nothing but what? Yes, 3 by under root a square plus x square is the answer. I hope this question is clear. Let us solve questions involving infinite series. So it is given that y is equal to cos x under root plus under root cos x plus under root cos x. So this is the infinite series that is going on. So there, but in this infinite series there is a pattern, right? What pattern is there that you people can tell me, sir, that after every cos there is under root cos, right? This is the pattern. So how do we solve these kind of infinite series is that you decide from where the pattern is getting repeated, right? I am repeating it, my words again. Decide where the pattern is repeating, right? So I could see that after this the pattern starts repeating itself. So I can replace this entire stuff which is getting repeated. Since it is an infinite series, if I had asked you question, so for example you just remove this, right? For example, you are not seeing this. So again what you will say, this entire term is what? Y, right? If you just leave this, you will still say this is y because this is an infinite series. So this question actually reduces to y is equal to under root of cos x plus y. Now you can easily solve this by squaring. So this becomes y square is equal to cos x plus y, and now do the simple process of finding dy by dx. So you want to find dy by dx, so this will be 2y dy by dx minus sin x plus dy by dx, and if you take dy by dx on the same side, you will get dy by dx is equal to minus sin x by 2y minus 1. So this is the answer we are actually looking for. This is the answer. As simple as that. Okay, so the problems of infinite series are very simple. You just have to think of where the pattern is starting to repeat. Think of start of repeating pattern. This is actually what you have to think of. Start of repeating pattern. Think where it is repeating. Okay, I'll take another problem so that you people can understand how do you actually have to pick the start of the pattern. So here it is given that y is equal to x, and you can see that it is an infinite series, right? A, b plus x, again you can say a. So now tell me, where is the pattern starting to get repeat again? The second time it is getting repeated. Tell me. So yeah, if you see, if I say just sir that it is getting repeated after this, then it is wrong. Okay, it is not getting repeated after this. Why? Because here is a, here is b. So it is not repeating, it is actually a different quantity altogether. So it is getting repeated at this particular point of time, after which you can see, if you again remove this particular component, right, this whole component, so this whole again will be called as y. So yes, now the pattern that we are getting here is y is equal to x upon a plus x upon b plus, yes, this is the stuff we were looking for. This is what is obtained in this particular question. So now if we just solve this, what you will get is something of this sort: a into b plus y plus x into b plus y. This is what you will obtain. Okay, and if we need to solve this completely, so this is now again a very simple problem. You just calculate it completely. That is the only challenge that is left. So this becomes y into a into b plus y, right, plus xy is equal to xb plus xy, right? And if you see clearly, this xy and this xy gets cancelled out. What you are left with is yab plus y square a is equal to xb. Now just differentiate. So if I differentiate, this becomes ab times dy by dx, right? And this will be what? Plus 2y dy by dx times a, and this will be b only, right? So now you have got the answer. So just collate the terms of dy by dx. So dy by dx will be what? ab plus 2ay is equal to b. So you will get the answer of dy by dx as nothing but b by a times b plus 2y. So this is the answer we were looking for, which is straight away in the option A. So you can see these problems of infinite series are rather very easy. They are very easy to solve. It's just that you have to figure out where the pattern is starting to repeat itself again. That's the only hurdle. I hope these two questions are clear to you. Okay, now let us take another category of question, which is higher order differentiation, and a very interesting problem and a very famous problem where you need to find the value of d2x by dy square. This is the target. Now first of all, let us clear some misconception. So if I have dx by dy, right, it is easily, we can say that dy by dx is nothing but, we can say dy by dx raised to power minus 1. These two things are completely equal, right? There's no problem at all. Okay, but if you want to write something of d2x square by dy square, right, and if you say, sir, I can write like this, so then this is not equal. Okay, this is the very important step. So actually you cannot here you can see that these two can be treated as a different quantities, but here these two cannot be treated as a different quantity. So the first formula that you should keep in mind, that d2y by dx square are not interchangeable, they are not reciprocal. You cannot write something like this. So the first target in this particular problem is to figure out what is the value of d2x square d square x by dy square. Okay, so now let us start again with dy by dx. So we know that dy by dx can be written as this. So up till this stage there is no problem. Okay, now we want to differentiate this particular quantity to form this. So what is the denominator here? Dy square. So that means this particular quantity is again differentiated with respect to y, right? This is what is the target, dx by dy. So let's apply this here as well. So this becomes d of dy, and this entire stuff is dy by dx whole raised to power minus 1. Okay, so now we also understand that we are very much comfortable when we are given derivative with respect to x. So this is derivative with respect to x, and here it is derivative with respect to y. So what I will do here, I'll do a little change here again. So what I will do, I'll divide and multiply by dx, right? So what I have done, I have multiplied and divided the same quantity by dx. Now again remember, this can be done only for the first derivative. You cannot multiply and divide by the second derivative. This rule is not applicable over there, right? So this will become dy by dx raised to power minus 1, and this dy will be written over here. Got it? So this is how you can write, and the beauty of this is now that you can actually solve this. So this is nothing but what? Yes, tell me. It is something like, you can say y raised to power, this is y1 raised to power minus 1. So this will become what? Minus dy by dx raised to power minus 2 into derivative of the inner function, that is derivative of, you just have to apply the chain rule now, derivative of this particular stuff, and you also have a dx by dy, this dx by dy. So if you collate all of this, so what is your d2x by dy square? Let's see. So it becomes minus times, this is dy by dx minus 2, right? This becomes what? This quantity will become what? Double derivative, which we actually know, that is d2y by dx square, and I can write this particular quantity as again dy by dx raised to power minus 1. So if you club this, this will be d2x square by dy square is equal to minus times dy by dx raised to power minus 3 d2y by dx square. Okay, so very important. In fact, I would highlight that this is one of the very important questions of this particular chapter, right? Re-revise this particular video for understanding thoroughly this particular concept. Okay, so this is nothing but, if we want to solve this, now you just put this value in this particular question. So you can see that dy by dx cube will cancel out because it is minus 3 and it is over here 3, and this is the minus sign. So the net answer that you will get for this particular question is 0, and we can say that this is proved. Okay, but importantly, this is not, question was not important to prove it to be equal to 0, but this was important because of this particular part over here, right? So re-watch the video again to understand this concept. Okay, let us take another problem to understand the concept of higher order differentiation. It is said fx is a function such that f double dash x is given in terms of fx. It comes out to be minus fx. Okay, and f dash is equal to, f dash x is given to be equal to gx function, and hx is defined as a function which is something like this, fx square plus gx square, right? So this is given, so I have written everything which is given in the question, plus h5 is given to be 11. So this is also given, and you are asked to find the value of h10 using all these things. So at the first, this question looks like very confusing, that where to start from. So even if I want to give you a hint that what you should people think of something like this. You are given double derivative here, so that means hint is double derivative will be used, otherwise there is no point of giving it to you. Double derivative is to be used, right? This is the biggest hint in this question. So double derivative is to be used, so immediately start differentiating this particular function. Till then you get f double dash x, because that is why it is being given. If you are not able to use, then there is no sense of giving it in the question. So if we start doing this activity over here, it becomes h dash x is equal to 2fx f dash x plus 2 gx g dash x, right? Okay, now we know some value of what? F dash. What is f dash x? F dash x is dx. So I can say this is 2fx and I replace the value here now gx, right? We know the value of gx. Plus I also know gx a bit here, right? So now let us see, we need g dash x here. I again rewrite this particular step over here. So this becomes f dash x is equal to gx. I'll differentiate this. So if I'll differentiate this, I'll get f double dash x is equal to g dash x. And we know from here that f double dash x is minus fx. So I can say g dash x becomes minus fx. Can you see this? So if I try and put it over here, so this becomes 2gx, and if I use this property of g dash x over here, so this becomes minus fx. Can you see what is the combined value now? All of them will get cancelled out, so it comes out to be that h dash x is 0. So when do you get a derivative of a function as 0? So this implies that hx is a constant function. Then only you can get its derivative 0, right? It's a constant function. So that means hx will be some particular value a for all x belonging to R, right? Irrespective of the value of x. So now comes the role of h5. Why h5 was given? So that means h5 is given. That means the constant value that has to be taken in this question is nothing but 11. So that means hx is 11. So whether I ask you h10, h20, whatever, the answer will be 11 again. So the answer to this problem is nothing but 11. Okay, so I have done this error that h5 is being asked. Yeah, so h5 is given that it is 11. So answer to this problem would be then none of these. Okay, I hope this problem is clear. Very important problem, very beautiful problem, and in fact if you can see, it is just a 3-step problem, but at the front it looks like a very difficult problem. So these kind of questions could be asked if they want to ask you a tricky problem. So this is one of those questions which I would say is tricky, and you can put this into the tough category also according to the paper. So though it is not tough, but according to paper standards, this would be called tough. So even if you think that, sir, I am not of this particular level that I can solve these kind of questions, don't worry. Alright, this would be a tough problem according to the standard of the paper. Okay. Now let us take a concept to understand how to find, how do you utilize inverse of a function in the topic differentiation. Okay, so g is the inverse of f and f dash x is this, so we need to find g dash x. Okay, so g is the inverse of this. So first of all, again we'll highlight the formula that we are going to use here, right? So what is the formula that contains inverse and its function? It is that if g of f, where g is the inverse of f, is nothing but the identity function x, or you can say the identity function. Please remember this. This is very important, very important stuff. Okay, so either f of g will be x, you can say this is the relation, this is the formula. If f and g are inverse of each other, if f and g are inverse of each other, okay, of each other. This is the property that we have to remember for these kind of questions. Okay, now let's start the question. We want to find g dash x. Now we are given g is the inverse of x, so either we can start from g of f x is equal to x, or we could start from f of g of x is equal to x. We can start from both the ways. Okay, I'll start solving and I'll tell you which is the step which is the correct one or the shortest one in this particular question. So you want to use f dash x, so that means somehow you have to utilize the derivative property. Let me just write it for you in this format, right? So okay, let's start it parallelly. Okay, so this is the step. So let's differentiate now. If I differentiate, what this would become? It will be g dash fx into, yes, f dash x is equal to 1, and here if I say, it will be f dash gx, okay, into g dash x is equal to 1. So at front, what you people think that will be useful? Either this one or this one. So many students tell me that, sir, we'll follow this particular step because you are directly getting g dash x over here. Okay, got it? Okay, so let's start with this step only. So it said g dash f dash gx. So you know the value of f dash, right? So you just need to replace this by yes. So this will be something this sort into g dash x equal to 1. Completely acceptable. In fact, this is the answer we are looking for. It is the correct answer, right? So this is the answer we were looking for. Got it? So this is the answer. But in fact, if you start from the other side, that is this component, then also this is right. Okay, this is the shortest step. If I have to tell you that how you will solve this, let's see. It becomes g dash fx into f dash x. So we know that the value of f dash x is x raised to power n is equal to 1, right? So it becomes g dash fx is equal to 1 plus x raised to power n. Okay, but we wanted g dash x, so you want this fx to be replaced by x. How you can do this? Again, see to this property. Check here. We said that f of g becomes x if f and g are inverse of each other. So here what I will do, I'll replace, for this what I'll do, I'll replace x by gx. Since this is an identity, I can do this. So this becomes g dash f of gx is equal to 1 plus gx raised to power n, and this entire quantity f of gx, since they are inverse of each other, becomes g dash x. So g dash x again comes out to be the same stuff as this particular answer. So both the methods are correct. Obviously this method is the simpler one, but you can get answers from both the sides. Do not worry about it. So this is how you actually apply inverse of a function in the questions related to differentiation. I hope this is clear. Let us take another problem to understand the concept of inverse functions with respect to differentiation. It says f is a bijection. So why this particular statement is given, that fx is a bijection? So we know that inverse of a function exists only when it's a bijective function. Exists only for bijective function. So this is the logic it is given, right? Otherwise you cannot solve this function, right? Satisfying f dash x is equal to fx. Now this is given. Now you are asked to find the second derivative of inverse function. So this statement means second derivative of the inverse function is equal to minus 1 by x squared. This is what we want to prove. So for these kind of questions, let us do a simplification. What I'll do, I'll take f inverse as equal to g, right? So I can reduce this step here as you are asked to prove that g double dash x is equal to minus 1 by x squared. This is what is being asked of you. Okay, this is what you want to prove. Let me just highlight it. This is what we want to prove. So again we know that if f and g are inverse of each other, they are inverse of each other, so they will satisfy that f of g is equal to identity function. I just taught you that in the previous question. F of g will be equal to x. So let us start from here, that I can write like this, okay, and then I'll differentiate. So I would say differentiate from this particular point. So what it will become, g dash fx into f dash x is equal to 1, right? And if you solve this, this becomes g dash fx is equal to 1 by f dash x, and since I know that f dash x is, yes, it is 1 by fx. This is what I can say, easily say. Okay, I hope up till this there is no problem, but still the question is not over. Why? Because we wanted to find out g double dash x. So let's differentiate again. So what I'll do, differentiate again this particular step over here. So this becomes g double dash fx, chain rule, f dash x is equal to, this would be what? Yes, you will treat it as, let's say I'll write it here only, fx raised to power minus 1. So this will be minus 1 fx raised to power 2, yes, into derivative of fx, that is the chain rule, you will get f dash x. You can clearly see that f dash x and f dash x gets cancelled out. Okay, so what is actually left out with us? Let me rewrite it again. It is that g double dash fx is nothing but equal to minus 1 by fx whole square. Okay, now you wanted x only, here it is coming to be gx. Question is over. You can just replace complete x by gx again, replace these two things. So this will become what? G dash f of gx, which is nothing but x. This will be f of gx, which is nothing but again x square. Or in fact you can just replace fx by x also, that is not a problem. Okay, because this is the input. So if this, what you can see this function like is that the input of double derivative of g is fx, then the answer will be minus 1 upon input square. So input is fx or x, this is one and the same thing, hence proved. This is what we were to prove, right? So this is how you can actually solve questions based on inverse of a function. Just revise both the questions so that you are thorough with the inverse part of the differentiation. Okay. Okay, so by this we come to the end of this particular chapter, and I'll be mailing you the worksheets as usual. Though the worksheet contains a lot of questions this time around, see to it which questions you feel are necessary that you should do. Alright, you need not do the entire question that are given, so just select carefully. In fact, there are two levels, level 1 and level 2, so you can, if you are comfortable with level 1, you can just directly skip to the level 2, and in the meanwhile just complete this particular topic from your board booklet. For example, in the CBSE we follow NCERT, so you can just finish up NCERT, and this is how you should actually study along with this particular online test series. Okay, and if you find any problem in the NCERT questions, this we have the video solutions available for each and every exercise. The important questions of each exercise have their video solutions already on your channel. Just go and watch them. Alright, so good night for today. We see you tomorrow with a new chapter.